Yeah, the manner by which physical and logical input devices provide input to an application program can be described in two terms of entities. Basically, I can call a measure as well as trigger as an entity, as two entities which are basically provided as an input for your physical or logical devices. So, what is this measure is it basically tells or takes what is being written from that particular device, that is the output. The measuring of output is done with the help of this device called as measure as well as trigger. What is trigger? This basically tells at what time it is being written, the particular output when it is being written. Basically these are the two entities you need to remember, which are basically used as an input for physical as well as logical devices. This is basically comes under consideration when you are programming some application. This entities comes into consideration when a program is being implemented towards an application. So basically we use measure to see what is being written and trigger when is being written. So what does a measure include? Measure can also include status information, that is whatever the program status, if it is still in execution or if the program is still running. With the help of measure you can check the status of that particular program. So this is about measure and trigger. Then you have some input modes with respect to, as you know, every application or a device consists of some modes with the help of which you can provide input to it. So similarly, devices, it also consists of some input modes. So we'll check out what are those input modes. We can obtain the measure of a device in three distinct modes. Um, each mode is defined by the relationship between the measure process and the trigger. So what does this tell? Basically, whatever the mode, I have defined three types of modes in this slide, right? So these three types of modes are basically distinguished by the relationship between measure process and the trigger process. As we saw, what does measure as well as trigger do? Measure is used to what is being written, and trigger is used to when it is being written. So I can define each mode as the relationship between these two, that is measure as well as trigger. That is, if I take request mode as one of the example towards the input mode, whatever the input you are giving is of type request mode, so I can tell this mode comes under the relationship between measure as well as trigger. I can just simply tell this all modes, these modes lies between measure as well as trigger. This is the simple logic of three modes. So the three different sample mode as well as event mode. So we'll check out one by one in detail. So what is request mode? The measure of the device which is not returned to the program until the device is triggered. That is, the measure, whatever the measure we use in the device while executing a program, it is actually not returned till a device is triggered. You can check out this measure as well as trigger which is being used in an application. If you are using it in an application, both are always linked here. The measure of that particular device is actually not returned until a device is triggered. So what happens here when device is triggered, in the sense which is basically giving an output, till that part the measure cannot be executed. Then this mode is standard in non-graphical applications such as C programs. That is, request mode is usually used in our C programs. This is basically not used in graphical applications, but with non-graphical applications we can use this request mode. So what is request mode? What are its terminologies? What is its input and output? So in request mode, input is buffered until the trigger is hit. That is, this input is being set into some memory. The temporary memory, which is a buffer, it is being stored in the buffer till the trigger is hit. That is, till you won't come towards the output part, I can say. For scanf, the trigger is the enter key. In your C program, what you will do, once you give the printf, you'll press and enter, so that you'll wait for the keyboard to enter the input, that is scanf part. So after scanf also, if you are pressing enter, then only it will go to the logic part, right, the control. Similarly, this is how the request mode works. This request mode will be waiting for the user for the further what I can say, further implementation or the further action to be performed. So check out, this is a trigger process here, this is a measure process, where there is a trigger is happening, so that a measure process happens. What happens in measure processes, it will be basically checking when the process, not when, what the process is happening with respect to that particular request mode. And if this is an application program written here, first the application program sends a request to the measure process. Whatever the measure, what it is waiting for here, what does the measure process do? What does measure does? It basically tells what the process is, that is what is the process. It will tell that particular process to this particular program, then the program starts its execution. That is simply you can check just a simple diagrammatic representation of request mode, that is a program is requesting for service from the measure process, and it this measure basically gives you the details of that particular request to the program. So then sample mode. First, I'll check out the sample diagram of sample mode. This is the program. This program is requesting sample from the measure process. Measure process is just returning the details of that particular sample. So this is how sample mode also works with respect to the application program. In sample mode, the input is immediate. That is, whatever the input the measure is been giving to the program is given immediately. There is no waiting process there. As soon as the function call in the user program is encountered, the measure is returned. Basically we use function calls in the program. If such kind of function calls are being encountered, the program is returned, the output of the program is written for that particular application. Then as soon as the function this is done, both request mode as well as sample mode are useful for the situations where the program guides the user. Check out this point. Both request as well as sample modes are useful for the situations where the program guides the user. That is, the program gives the instruction to the user, but are not useful in the application where the user controls the flow of the program. When is this? When are these modes useful? Is that is request as well as sample mode. Whenever the program is giving instructions to the user, I can use this request as well as sample mode. But these kind of requests are not being used in the applications where the user controls the flow of programs. That is, wherever the user is using the program for his application. So this is the advantage as well as disadvantage of simple sample as well as request mode. Then we have event mode. What is event mode? As we have studied event queue in your starting module, that is in your first module, what happens in event queue? Basically a function will be waiting for some functionalities to be completed, so that the other process is being executed. Similarly, what is a event? Event is nothing but some kind of operations is being performed in that particular process. In event mode, each time a device is triggered, an event is generated and placed into a event queue. Check out, as I told, the event queue comes into consideration here. From here, there are two approaches. Once you have found an event queue with the help of some device, when it is being triggered, we have some approaches here. There are two approaches. What is the first approach? The program can then get events of the queue and service them. That is, the program waits for the user's instructions and it will come out of the queue with respect to the event and then execute them then, or it will take a callback function with specific type of events when it comes in front of the queue. Then the particular execution is automatically executed. That is, one is servicing the event from the queue and then calling back that particular function with respect to the program. So these are the two approaches which is being used in event mode. What is the first approach? You are just servicing the event, taking it out from the queue, and then you are calling back the particular function of that particular event. Check out the whole process where event mode is being executed here. This is a program written here. There is a trigger process, measure process, as well as event queue. These are basically the previous part execution done here. Suppose a program gives an await time for the event queue. What happens in the event queue? It just takes out the event from that particular queue and then services it to that particular program. Or this might be a callback function as well. It will just call back that particular function of that particular event and then execute that particular function in the program. So this is about event mode. So these are the simple three types of modes. That is uh, event mode. One is event mode, sample mode, as well as request mode. We studied. Then, as I told, there is a topic called clients and servers, which is actually related to your networking topics. So let's see what are clients and servers. As I told, the module is full of input as well as output devices, and then input as well as interaction of the such kind of input devices. So we'll check out what are these clients and servers. So what is a server? I can tell server is something that can perform tasks for clients. That is, whatever the client is giving a specific task for the server is meant to perform that particular task and return it to that particular client. It might depend on the server. That is, the request from the client can be taken and then it can perform the operations. That is the working of server. As I told, an example of an Wi-Fi. If I take Wi-Fi as a server, who are the clients for the Wi-Fi? The users, right? Who uses the internet from the Wi-Fi? So this is the best example for client and server. Then, clients and servers can be distributed over a network or contained entirely within a computational unit. That is, whatever the clients and servers we use, basically it comes under some network. If there is no network related with respect to client and servers, there is no functionality happening between the client as well as servers. What happens when there is a network? When there is a network found, this basically the clients or servers are basically distributed with respect to that particular network or with respect to some computational unit. Then open shell programs are clients that uses the graphics servers. Suppose whatever programming we are doing, which is the server here, which server we are using in the program, can someone guess? What is the this thing library you have installed before executing the program? Isn't it the glut library? You have installed the glut library. I can tell glut library as the server, and the clients using the functionalities of glut library is nothing but the clients there. So this is an example of client servers. Then, coming on to the diagrammatic representation of clients and servers, these are some of the servers connected. That is, the systems which are being visible to you are the graphics servers, the print servers. These are the workstations used here, compute server, file server. This is some client. These are some of the servers where they are using huge number of applications. With the help from these servers, we can extract some technologies, or I can say some functionalities. That is the working of clients. What does clients do? Clients basically extract functions or working from the servers. Then display list. What is a display list? Basically, display list is used to illustrate how we can use clients as well as servers on a network to improve interactive graphics performance. Display list is nothing but first we saw some of the display devices, right, in the um, first module. What are the display devices? We saw some different display devices. One is CRT monitor. What does CRT monitor refer to? What does cathode ray tube does? Simple question. What CRT monitor does? Don't know, forgot. It will just display an output, right? The image or a video which is being displayed with the help of the functionality which is used behind the screen. So that is the usage of a CRT monitor. The functionality depends with respect to number of pixels connected to it. So coming on to the display devices, basic that is display list. Basically, display list tells us how we can use clients and servers on a network to improve the performance. That is, with the help of display list, we can actually improve the performance of clients and servers. That is, it gives a procedure how to use clients and servers. Basically, it introduces a display processor architecture. Basically, I can say this is an display processor architecture which is shown here. This architecture has display processor along with the host processor. That is, this is a display processor which is actually called as GPU. It also consists of host. I can call this as a host processor as well. What does this host processor does is, the host processor basically processes the user program to generate a compiled list of instructions. That is, it processes whatever the user writes a program, it processes that particular program and generates a list of instructions which can be passed to the display processor next. Then whatever the list, that is, I can call it as a compiled list in the memory called as display memory or the display list or a display file. What the output of the host as well as display processor is basically a display file. What is this display file? Display file is nothing but a list which is basically stored in the memory. That is nothing but the display processor memory. As each and every processor consists of some memory, similarly, this display file is nothing but a list which consists of some instructions which is basically stored in the memory. So as I told, what is the display processor is, display processor, I can call it as a processor which is basically designed to interpret the instructions which is used in the display file or the display list. That is, whatever the commands or the instructions which are being given in the display file is basically executed by display list, that is display processor. Then once the display list is sent to the display processor, the host is free with respect to the other task. That is, whenever the display list which consists of a display file, that is, whatever display file consists of some list of instructions, right? So whenever this display file sends some instructions to the display processor, the host become free because all the instructions as well as executions are done by these two parts, that is display processor as well as display file. Now the host is free. The display processor executes the instructions which comes from the display file, then it will avoid some fluctuations happening with respect to host as well as display file. So that is, whenever once this particular task is done, whatever the execution is done, it is actually displayed in the display CRT monitor. So this is about the display list as well as display processor, how the display processor works. Then we have some modes here with respect to display processor. That is coming on to our generation, how this display processor is being used in day-to-day life, or if it is used or not. We'll check out. The display processor has become the graphic servers, and the user program has become a client. That is, whatever the display processor will be using, it is used as a server, and the program is actually used as a client. Okay, then the issue is not the refresh rate, but the amount of traffic between the client and the server is the issue. So what is the issue regarding the display processor? That is nothing but the traffic. That is, whenever there is a file or a list sent to the display processor, the host should be waiting for the message of the display processor that if it is busy or if it is empty, so that the host can send some instructions or not. So this is the time I can say there is some delay happening here. So the host should be wait. I can tell there is a traffic created here. So that is one of the issue regarding the display list, that is the display processor. Then we can send graphical entities to a display in one of two modes. That is, whatever the entity we have, performance we have with respect to the display, we have with respect to two modes. One is immediate mode as well as retained mode. What happens in immediate mode is, basically in immediate mode, as soon as the program executes a statement, if you have some statement in the program which needs to be executed, as the program executes that particular statements, it basically defines a primitive. So what is that primitive? This primitive is basically sent to the display, hence the memory is not required to store display information. So this is an advantage of using immediate mode. You can actually reduce the memory here. So as I told, check out the point. If the program wants something to be executed, if it executes a statement, it consists of some primitive. If it basically defines a primitive, this is basically sent to the server for display. It is directly sent to the display, but you can check there is no memory use. So that is one of the example here, that is advantage. In this kind of mode, we basically redisplay the primitive in new position, as we don't require some memory. That is, we keep on displaying the primitive so that there is no memory used here. For complex objects in highly interactive applications, the process can cause considerable quantity of data to pass from the client to the server. What happens here, if there are some complex objects to be executed, what happens at that method? It basically uses some huge amount of data with respect to the client, so that it can pass that particular data to the server as well. So this is about the immediate mode, how we use it in the display processor. So in this display list, one of the important question I can say is the display processor architecture, which was explained the diagram. So we started with modes. These modes also can be asked for 5 marks. One is immediate mode as well as retained mode. So what is retained mode is, basically we define an object once, then put its description into a display list. When this retained mode comes into consideration is, basically after the definition of object. That is, you for defining a object, you have to explain something, right? That is, you have to give the details of the object, so that it can be described efficiently. So as we define some object, we have to put the description, which is actually displayed onto the display list. The display list is stored in the server and redisplayed by a simple function call issued from the client to the server. That is, whatever the message you have stored in the display list is basically sent to the server and again redisplayed by the function call, which is basically used in client and server approaches. So this is also one of the advantage of using retained mode. That is, there is no much memory used here. So what is the advantage? Makes good use of hardware. As I told, it is just happening in the client as well as server. There is no memory used here. So that is good usage of hardware is done here. Then computation as well as graphics can be implemented by using such kind of hardware. So what happens in the disadvantages? If, as I told, there it uses just client and server, but it is using the memory which is stored in the server, right? but it is not using the memory which is stored inside your program. It is just using the memory which is being stored in the server. Then creating of list, that is overriding of the list which is being created. As you can see, as the definition says, you can create huge number of lists. Overwriting or overheading of that such kind of list can happen in this particular mode, that is the retain mode. Then we have some another definitions of execution of display list, that is definition and execution of display list. So what happens in definition is, display lists have much in common with ordinary files. There must be a mechanism to define or create them, as well as to add them or manipulate them. We use actually some mechanisms for the display list so that we can define it, execute it, or manipulate it. In OpenGL, basically display lists are defined similarly to geometric primitives. Whatever the primitives we use, such as GL polygon, GL triangle, and all, similarly in OpenGL, display lists are defined in the same way. That is, OpenGL has small set of functions to manipulate display list and placed only a few restrictions on display list content. So we'll look out some examples so that we can see their usage. One example where, as I told, the display list are defined similarly to as geometric primitives. Each display list should have a unique identifier, that is a unique name given to it. Now, how to create a display list is, first I will give GL new list. What happens in GLU new list? It basically defines a type of primitive, and it sends that kind of primitive to the server. What happens in hash defined box one? It is basically creating a unique identifier here. That is, unique name is being defined with respect to the program. So similar name is being given here, kind of primitive used. Then I will begin with the type of primitive which is actually not displayed. That is not displayed here. The type of primitive, that is GL polygon. We have seen the functionality of GL polygon. GL polygon is used to define the type of primitive. Primitive here is the polygon. I am giving the color of the polygon as red, and then I am defining each and every vertices of the polygon. Then whatever the first line we have defined, as I told, is an unique identifier given. Basically, it is also a directive which is basically used to define the program. In the second line, I have defined something called as a GL compile with respect to the box, the unique name. What does this GL compile does is, it basically tells the system to send the list to the server, but not display that particular point onto the display screen. Now, this whole line GL new list is actually at the beginning of that particular polygon. It will end at GL end list. As I have started the list here, I have ended the list here. So this is how the display list is being defined with respect to the geometric primitives. So how this execution happens, that is, once the program is coded, now how execution happens, basically as we are drawing a polygon here, polygon as I have defined here, I should draw a polygon. To draw such kind of polygon which is being defined here, we have to call an function call with respect to this polygon itself, which is actually named as GL call list, which is actually similar to that of OpenGL other commands as well. So that was an example. Check out as whatever I told here. If you want an immediate display of the contents, we can use this kind of flags. Each time that we wish to draw the box on the server, I'm just calling, I'm executing by calling this particular function. Because the call to set the drawing color to red will still be in effect, you usually see display list with the following at the beginning. That is, these kind of display list can be defined at the starting. At the end, I am just using these kind of attributes.